If you enjoy operating portable, things like POTA, SOTA, Field Day, and so forth, or if you just like taking your radio out in the backyard and stringing a wire up and seeing what will happen, these different modes, these different techniques always have one thing in common, and that's the battery. You got to have a battery that will run your operation. It's a good plan. Now, no matter what kind of charging regimen you have for your batteries, no matter what, even if you just go to the store and buy new batteries every time, it's not a bad idea to check the battery to make sure it's going to be okay before you start your operation. Like it takes a little bit more than just measuring the voltage. Just open circuit voltage tells you a little bit about the battery, but not everything. The main thing it'll tell you is if the battery's dead, but that's about it. But if you really want to truly test the battery, you need to load it, put some kind of a load on it, depending on the kind of battery. It'll depend on what kind of load, just to make sure it's working. Not to run the battery down, not to characterize the battery. Just say, yeah, it'll put current through this resistor, therefore it will probably work. But that's a pain in the butt. You got different kinds of resistors, and you got this kind of a rat's nest of hooking up the wires, hooking up the meters. So if you're like me, you just don't worry about it. You just say, well, I hope it works. But I always wanted a real simple, plug it in and tell me if the battery is going to work for this particular operation. Just a simple little device, self-contained, plug the battery in. It says, yeah, this battery is capable of running the operation. I just happen to have a whole bunch of 15 ohm 20 watt resistors. You put 15 ohms across 12 volts, it's about 800 milliamps, more or less, most of an amp. And that's a pretty good test. Just most small batteries, if it can deliver that, it's probably going to work for you right out in the field. It's probably charged enough. Or you could put two of them in parallel. It's a little bit more current, and keep paralleling them until you're really loading the battery down to where you think, yeah, that's going to be okay. Again, this is just a yes, no, a go, no go test. So what I want to do is build some kind of a fixture that would make it really easy. The bottom line on this is easy. Go, no go, yes, no. The green light comes on, you can go. That's sort of a test. And so I've come up with a little test fixture that I want to show you that has really worked out real well for this. So here's what I came up with. This is the test fixture. It has an Anderson connector on it. You just plug in the battery. Anderson connector assumes that it's mine, so I put Anderson connectors on my field batteries, so I just plug them in. I don't have to worry about clip leads and adapters. And this is a bunch of resistors. The switches over here take care of putting none in the circuit, 1, 2, 3, 4, and so forth. These resistors are kind of binary weighted in terms of how they parallel. 1 in parallel, 2 in parallel, 3 in parallel, 4 in parallel, etc., like binary rated. This is just how many switches I had, how many resistors I had. There's nothing magic about it. However, because I happen to have enough, it's around 70 watts, which is a pretty good load for just testing if you got a 100-watt battery, 100-watt rig you want to run, you plug this thing in and it'll tell you if the battery will probably survive the operation. So anyway, it's got all this stuff, the switches, a shunt resistor for the meter. We'll talk about that in a sec. And then the meter itself. So we'll take a little closer look at the guts of this thing. Okay, this is probably good enough. So this will switch in no resistors, 1 resistor, 2 resistors, and so forth. And then the meter, and then we just got a battery, got the Anderson connector, so I don't have to mess around with clip leads and screw things. I just plug into my battery that I'm going to take in the field anyway, so it's already got the Andersons on it. Plug that in. And the voltmeter, there's a voltmeter that, turn those off. There we go. Okay. So I switch out all the resistors, so that's the open circuit voltage. And this is really typical. You stick a voltmeter on, it says 12 volts, 12 and a half volts, close enough, it'll probably be fine. But as soon as you put a load on the thing, the voltage drops down. See, even at 2 amps, it's down to 11 volts. 3 amps, it's 10 volts. So this battery, even though the open circuit voltage says, yeah, it's probably good to go, it's not good to go. And this is what's nice about it, is that it's just simple. Plug it in, and even if this thing may have been on a charger for 2 months, maybe something's wrong with the charger, maybe something's wrong with the battery, but now you know before you go out in the field. So anyway, the way this thing works is, like I say, the bottom line, simple. I've got what I've got is one of these things you get on Amazon. It's a volt current meter. They make two versions of this. One that's got the shunt inside. It's good for about an amp or something like that because of the little shunt that's in the circuit. The current goes through this thing and then it measures the voltage across. It does a little bit of math and decides that that really is current. And then there's another kind that I put in here that can stand a little bit more current, and it requires an external shunt, an external resistor, very low value resistor. And all the current goes through the resistor, it measures the voltage across it, does a little math fanciness, and displays it as current. And the shunt looks like this. So it's a big old fat thing. This thing's way overkill for this. This shunt's good for around 100 amps or something, but that's what they had. So all that's down inside of here, the shunt, the switching. It's real easy to use, real easy, and that's the thing I like about it. You just real quickly before you go out in the field, test if your battery's any good, and you get a good feeling if you're gonna make it. These things here are 3D printed, so they're just exactly. That's one nice thing about a 3D printer. You can make exactly the thing you need. You don't have to have a box that's too big or too little. This little display here is on a neat little panel that's kind of cool. And of course there's no on off this. I think it's either you have the battery plugged in or you don't. So that's it. That's my little battery tester. Kind of proud of that. It's kind of just so danged easy. This is not for characterizing the battery. You could plug that thing in and watch the battery go down and piece of paper and write stuff down, but no, that's not what this thing's for. It's simply to test battery if it's good enough to take out in the field. Alrighty, 73 guys, good, as they say, good luck in the contest.